Welcome to the deep dive. I want you to start by just picturing something for me.
Okay, I'm ready.
So you are sitting in a tiny, vibrating metal box. The noise of these twin engines is absolutely deafening, like vibrating right through your teeth.
Oh, wow. Yeah, that sounds intense.
Right. You smell aviation fuel, hot oil, and you look out the window, and literally all you see in every single direction, north, south, east, west, is just this featureless gray ocean, blending perfectly into a featureless gray sky.
And you've got no modern tech. Relax.
Exactly. You don't have a GPS. You don't have a smartphone. You were trying to navigate across thousands of miles of open water using nothing but like paper maps, a basic magnetic compass, and a radio that is mostly just spitting bursts of static into your headset.
It is a profoundly isolating environment to, even try and comprehend today. But it perfectly captures the physical and psychological reality of aviation in the 1930s and 40s.
Yeah.
I mean, aviators of this era were entirely at the mercy of their analog instruments and, well, whatever the immediate atmospheric conditions were right outside their windshield.
And that really sets the stage for what we're doing today. Our mission is to explore that razor-thin margin between triumph and tragedy in early aviation.
It really was razor thin.
It was. We are pulling from a really fascinating stack of sources today, including archives from Britannica, History.com, the National Air and Space Museum, and a specialized report called The Final Transmission.
Lots of great material there.
Oh, absolutely. Our goal is to look specifically at the extreme uncertainty of navigation and communication during this era. And to do that, we're using the most famous disappearance in history as our primary lens.
Amelia Earhart's final flight.
You got it, Amelia Earhart.
She really serves as the ultimate case study for this era. I mean, by the time of her disappearance in 1937, she was far more than just a pilot.
She was a celebrity.
Oh, a massive international icon. She had totally cemented her legendary status. In 1932, she became the first woman to fly solo across the Atlantic. She was consistently setting altitude records, pushing boundaries for women's rights, and frankly, fundamentally redefining what the general public thought was even possible in a machine.
Yeah, she was a global superstar, and she was attempting this unprecedented 29,000-mile flight around the world right along the equator in a twin-engine Lockheed Electra.
Which was a highly advanced plane for its time, but still.
Still, yeah. And the incredible thing is, by July 1937, she and her navigator, Fred Noonan, had completed the vast majority of it.
They had flown, 22,000 miles already?
Exactly, 22,000 miles. They just had this one brutal stretch left across the Pacific Ocean, which brings us to the terrifying logistics of her final flight leg.
Yeah, July 2nd, 1937.
Right. They depart from Lae, New Guinea, heading for Howland Island.
And I think we need to contextualize what Howland Island actually is, because it is not some massive landmass.
No, not at all.
It is a remote coral atoll in the Central Pacific, basically a tiny strip of land just a couple of miles long, barely protruding above sea level.
Here's where it gets really interesting. Finding a 2-mile strip of coral in the middle of the Pacific Ocean with 1930s technology required a level of mathematical precision that is honestly almost hard to fathom.
It's basically impossible.
Right. The distance they had to cover was 2,227 nautical miles over open ocean. Finding Howland Island with that tech was like trying to hit a single specific grain of sand on a beach.
Wow.
After walking a mile with your eyes closed.
Yeah.
Let's just think about the geometry of that for a second.
Okay.
If your compass heading is off by just 1 single degree, you drift about 1 mile off course for every 60 miles you fly.
Which adds up incredibly fast over that kind of distance.
Exactly. Over a distance of 2,200 miles, a 1-degree error means you are nearly 40 miles away from your target. You don't just miss the center of the island, you miss it completely and fly straight out into the void.
And that mathematical reality is exactly why navigation was such a monumental task back then. Over the open ocean, navigators like Fred Noonan relied almost entirely on celestial navigation.
Using the stars.
Right. You use a sextant to measure the angle of the sun and the stars relative to the horizon, and that helps you calculate your position.
But didn't they run into weather issues?
They did! On that specific critical leg of the journey, they encountered heavy overcast skies.
Oh, no.
Yeah, so the clouds effectively blindfolded them, and when you cannot see the stars or the sun, you are forced to rely on a backup technique called dead reckoning.
Okay, let's unpack the mechanics of dead reckoning for a second, because this is where the danger really lies. It's essentially calculating where you should be based on your speed, your compass heading, and a clock, right?
That's the basic idea, yes.
But It assumes you know exactly what the wind is doing to your aircraft. I kind of think of it like trying to walk across a pitch-black room by counting your steps.
That's a great analogy.
You might know exactly how many steps it takes to reach the door, but what you don't realize is that the floor is actually a slow-moving treadmill.
Right.
Your math is totally flawless, but the invisible environment is secretly pushing you way off course.
And that invisible environment is wind drift. If you have a headwind that you cannot measure because, the cloud cover prevents you from tracking the ocean surface below, you might be flying significantly slower over the Earth than your actual instruments indicate.
And over 2,200 miles.
Over 2,200 miles, a 20-mile-per-hour headwind compounds into hundreds of miles of error. And it relentlessly eats into your fuel margin.
Which is terrifying.
It is. In early aviation, a minor fuel miscalculation didn't just mean you arrived late. It meant the engine starved and you went into the ocean.
Which means visual navigation was fundamentally unreliable under those conditions. So the only true safety net they had left was two-way radio communication.
Yep.
Now, the U.S. government knew exactly how perilous this specific leg of the flight was, so they stationed a U.S. Coast Guard cutter, the Itasca, right off the coast of Howland Island to, guide her in.
And the Itasca was heavily equipped, too. They were fully prepared to act as a beacon.
Right, they had a whole setup.
Oh, absolutely. They were listening for her frequencies, and they were actively burning miles of thick black smoke from their ship's boilers to create this massive visual signal.
Designed to be seen from the air for miles around.
Exactly.
Wait, I have to challenge this narrative for a second. We're setting this up as a story of technological failure. But, Earhart had a two-way radio.
She did.
The Coast Guard had a massive ship pumping thick black smoke into the sky. If you are a pilot who knows you are burning into your final reserves of fuel, standard protocol dictates you communicate clearly and coordinate with your beacon.
That's the logical assumption.
So at some point we have to ask, was this actually just pilot error? I mean, did the sheer psychological panic of low fuel cause her to just abandon protocol and fly erratically, missing a gigantic smoke signal that was right in front of her?
It is a totally logical assumption to make, but we really have to look at the severe limitations of the radio infrastructure itself before we assign blame to pilot panic.
Okay, fair enough.
What's fascinating here is how the technology intended to save them operated under rules of physics that actively hindered them.
How so?
Well, 1930s high-frequency radio technology was highly susceptible to atmospheric interference. It's a phenomenon where signals basically skip off the ionosphere unpredictably.
Oh, right. Skip distance.
Exactly. The Itasca was receiving these frantic, sporadic transmissions from Earhart. At one point, she radioed 1/2 hour fuel and no landfall.
That is chilling.
It really is. But the reason she couldn't see the smoke wasn't panic. She was likely battling dense cloud cover, and due to that compounding wind drift we just discussed, she was simply scanning the wrong piece of the sky.
Wow. Okay, so that brings us to the final famous transmission, the one that has kept investigators basically analyzing the data for almost 90 years.
The famous one.
Yeah. She keys the microphone and says, "We are on the line 157337 running north and south."
And that single transmission is the absolute key to understanding the mechanics of the tragedy.
Break that down for me.
So in celestial navigation, a line of position is a straight line drawn on a map. Earhart and Noonan had likely taken a bearing on the sun at sunrise.
Okay.
Based on the sun's angle, they drew a diagonal line across their map that passed perfectly through Howland Island. The numbers 157 and 337 refer to reciprocal compass degrees on that exact line.
I see.
So 157 degrees points southeast, and 337 degrees points exactly the opposite, northwest.
So she is basically telling the ship that she knows mathematically she has reached that specific diagonal line.
Exactly.
But the problem is, a line goes on forever. Without a second intersecting line, what navigators call a cross-bearing, to create an X marks the spot, she has no idea where on that infinite diagonal line she actually is.
And that is the devastating reality of the geometry. Because her radio signals were too weak and intermittent, the Itasca just couldn't lock onto her signal long enough to use their own radio direction finders to establish that cross-bearing.
So they couldn't give her the intersecting line.
They couldn't. So when she said running north and south, it meant she was literally flying her plane up and down that single diagonal line of position, desperately hoping the island would just, appear out of the clouds before the fuel gauges hit zero.
Oh my God.
Yeah, it left the rescuers on the ship completely paralyzed. They were guessing whether she was 100 miles north of the island flying away from it or 100 miles south.
Okay, let's unpack this.
Yeah.
The fact that a pilot can have the technology to talk across the sky,
Hmm.
yet is just primitive enough to leave them completely stranded, it really shifts how we look at this entire era.
It does. It changes the whole context.
Right. And Earhart's vulnerability to a single failing variable wasn't unique to her flight. When we analyze the sources, we see how frequently in early aviation, one small mechanical or communication error cascaded into a massive, baffling disappearance.
Yeah, it was really a systemic vulnerability baked into the DNA of the era. I mean, the mechanical capabilities of the aircraft were advancing at a very rapid pace.
Our planes are getting faster and bigger.
Exactly. But the navigational infrastructure required to actually support those machines over open water, it simply did not exist yet.
Let's look at how this played out just 8 years later with Flight 19.
Ah, the Bermuda Triangle story.
Right, the famous one. It's December 1945. 5 Avenger torpedo bombers take off from Florida for a routine practice flight over the Atlantic.
Routine being the operative word.
Totally routine.
Mm-hmm.
The weather is reported as perfectly average, but during the flight leader's compass begins to malfunction.
And Flight 19 perfectly illustrates how a simple mechanical failure morphs into a fatal psychological trap.
How does that happen?
Well, when a pilot becomes disoriented over featureless open water, their own inner ear and sensory perceptions will actively lie to them.
Really?
Yes, they will physically feel like they are flying straight and level when they are actually banking or even flying in a massive circle.
That is terrifying.
Ground control just listened helplessly as the pilots argued over the radio. They were completely disoriented about their location because they had totally lost trust in their instruments.
And they just ran out of fuel.
They eventually made the grim mathematical calculation that once the first plane drops below a certain fuel threshold, all 5 would ditch into the sea together.
5 massive military planes vanished without a trace simply because a magnetic compass stopped pointing north.
It's incredible.
And it wasn't just compasses that caused these cascades. The British South American Airways flight, the Star Tiger, in 1948 shows how even tinier failures compounded.
Oh, the Star Tiger, that's a textbook example.
Yeah, they were flying from the Azores to Bermuda. And before takeoff, they noted a broken cabin heater.
And a broken heater is a prime example of the cascading mechanical errors we're analyzing today.
I mean, a broken heater.
Right. In a modern context, a broken heater is just a passenger comfort issue. You hand out some blankets.
Yeah, exactly.
But in an unpressurized 1948 airliner, to keep the passengers from freezing to death at high altitudes, the pilot was forced to make a seemingly minor adjustment. He had to fly the plane extremely low at just 2,000 feet.
But the physics of flying at 2,000 feet change everything about the fuel consumption, don't they?
Dramatically. At lower altitudes, the air is significantly denser.
Okay.
And flying through dense air creates an enormous amount of aerodynamic drag, meaning the engines have to work much, much harder to maintain the same speed.
Oh, wow.
So that single decision to keep the cabin warm caused the Star Tiger to burn through its fuel supply at an exponentially faster rate. They completely eliminated their safety margin.
So when they hit bad weather.
Exactly. When they likely encountered unexpected headwinds, which investigators later deduced from weather patterns, they just didn't have the fuel reserves to fight through it. 25 passengers and 6 crew members vanished into the Atlantic.
It's so sobering. We look at things like the Bermuda Triangle or these plains swallowed by the Andes Mountains, and human nature makes us want to assign some supernatural or deeply mysterious cause to it.
We want a story.
Right. But really, it's just the harsh mathematical reality of early flight. One broken heater forces a low altitude, which causes high drag, which burns the fuel, which drops the plane into the ocean. There is zero room for error.
Zero. We constantly crave complex narrative explanations for complex tragedies, but the mechanisms of failure are almost always brutally simple.
Yeah.
Consider the Stendeck mystery.
Oh, yes, stand it.
In 1947, a flight vanished in the Andes Mountains, and the absolute last thing the ground operator heard was a frantic, cryptic Morse code message spelling out the word Stendeck.
And for 50 years, that word fueled incredible urban legends. I mean, people claimed it was an anagram or proof of secret military interventions or something supernatural because it just made no linguistic sense.
It remained a mystery until the late 1990s when glacial ice finally melted and revealed the physical wreckage.
And what did they find?
Well, an in-depth investigation found that severe weather and downdrafts caused the crash. And that seemingly supernatural message, Stendeck. It was just standard World War II aviation phrasing typed out on a Morse code key in a frantic, desperate hurry as the plane went down.
What did it stand for?
It stood for severe turbulence encountered, now descending, emergency crash landing.
Wow. Severe turbulence encountered, now descending, emergency crash landing. It was just a desperate plea for help that was tragically misunderstood for half a century.
Precisely.
And that brings us to a really crucial point regarding Amelia Earhart. When a plane vanishes due to these technological cascades, when there is no black box pinging, no physical wreckage to examine, no final definitive goodbye, it leaves a terrifying void of information.
It does.
And how do human beings react to a void? We immediately fill it with theories.
We absolutely abhor a vacuum of information, especially when it involves a cultural icon like Earhart.
Definitely.
The U.S. government recognized the public weight of this instantly and launched what was at the time the most expensive air and sea search in American history.
The logistics of the search alone tell you how impossible the task was. For 16 days, 9 naval vessels and 66 aircraft scoured the Pacific.
It was massive.
They searched an area of the ocean roughly the size of Texas. It cost $4 million back then, which translates to over $88 million today.
Staggering amount of money.
And they found absolutely nothing. Not a life raft, not an oil slick, not a piece of floating debris. She was legally declared dead in January 1939. But human curiosity means the search didn't stop with the government.
No, private expeditions have relentlessly pursued the mystery for decades.
Right.
Organizations like Nauticos have launched multiple deep ocean expeditions using highly advanced side-scan sonar. They constantly refine their search grids based on historical weather patterns, tide charts, and recalculations of Earhart's potential fuel consumption rates.
Even as recently as 2024, a group called Deep Sea Vision released sonar imagery showing an anomaly on the ocean floor that perfectly matched the dimensions of a Lockheed Electra.
Oh, I remember that. It made global headlines.
It did. But after further review, it turned out to just be a rock formation. The ocean is incredibly vast and highly adept at playing tricks on our technology, which is exactly why the theories have grown so diverse over the years.
If we connect this to the bigger picture of how we process historical mysteries, you can basically categorize the Earhart theories into a spectrum ranging from scientifically robust to complete fiction.
Okay, let's hear them.
The official U.S. government conclusion, and the one maintained by the vast majority of aviation historians and engineers, is the crash and sink theory.
Which is just the math.
Right. The mechanics dictate she simply ran out of fuel, ditched the aircraft into the ocean, and it sank thousands of feet to the bottom.
But then you have the Nicobaro hypothesis.
Yes.
This is the intensely debated idea that Earhart and Noonan didn't crash into the open water, but managed to glide onto a different uninhabited coral atoll called Nicomaro, which was somewhat along their line of position.
It's a very popular theory.
Proponents of this theory point to tantalizing artifacts found on the island over the decades. Vintage tools, pieces of plexiglass that match aircraft windows, and even bone fragments, suggesting they lived there as castaways for a short time before perishing.
It is a deeply compelling narrative because it offers a sliver of agency and survival, however brief, rather than immediate tragedy.
Yeah, people like that idea better.
Exactly. However, from a purely analytical standpoint, it remains unproven. None of the artifacts have been definitively linked to Earhart or the Electra.
Right.
And from there, the speculation detaches from physical evidence entirely. Because of the geopolitical tensions in the Pacific in 1937, with Imperial Japan expanding its territory right before World War II, a theory took root that Earhart was actually conducting a secret photographic spy mission for the Roosevelt administration.
Yeah, that theory suggests she was captured by the Japanese military after going off course to spy on their occupied islands. And the geopolitical projection gets even more intense.
It really does.
Some theorists claim she was coerced into becoming Tokyo Rose, the infamous collective of female English-speaking radio broadcasters who spread pro-Japanese propaganda to Allied troops.
Which is quite a leap.
It's a huge leap.
Yeah.
Others believe she survived the war, was secretly repatriated by the U.S. government, and lived out her life quietly under an assumed identity in New Jersey.
As an analyst looking at historical data, you have to approach these theories with balanced skepticism.
Of course.
The fuel starvation theory aligns perfectly with the known physics of the Lockheed Electra, the meteorological data of the day, and the exact phrasing of her final radio transmissions.
The math checks out.
It does.
Yeah.
But the complete lack of physical evidence naturally invites this kind of wide-ranging speculation. When society doesn't have a piece of twisted metal to point to, people will project their own cultural anxieties, like the fear of approaching war, onto the mystery.
So what does this all mean for her legacy? I mean, we have spent almost 90 years obsessing over the mechanics of her disappearance. But as Doris Rich, one of Earhart's biographers, astutely points out, by vanishing, she became legendary.
That's a powerful quote.
I think there's a profound tragedy in that observation. The mythology of her final fatal flight has completely overshadowed her actual tangible accomplishments on the ground.
It is a highly valid critique of how history remembers her. We memorize the mystery of how she died, but we often overlook the substance of how she lived.
Right.
She was not just a pilot who miscalculated wind drift. She was the first president of the 99s, an international organization of female pilots that is still active today.
Oh, wow, I didn't know that.
Yeah, she designed and debuted a functional clothing line specifically for active women. She served as a career consultant for women at Purdue University, actively working to dismantle the constrictive social norms of the 1930s.
She basically spent her life proving to the world exactly how high women could ascend in fields dominated by men. But the ongoing, insatiable mystery of her disappearance makes it almost impossible for the public to assess her career separately from that final day of radio static.
Which brings us firmly back to the reality of what occurred in that cockpit.
Yeah.
The extreme isolation, the desperate reliance on dead reckoning, the compounding variables of invisible wind, dense air, and a radio system that could only broadcast fragments of hope before the fuel ran dry.
You know, for you listening to this right now, well, it is probably very hard to really internalize that kind of isolation.
It's almost unimaginable today.
It really is. We live in an era of absolute constant connectivity. We have a Find My app on our phones that uses a constellation of satellites in space to locate a misplaced pair of earbuds down to the specific foot in our living room.
It's incredible when you put it like that.
It is deeply unsettling to remember that the ocean is so incredibly vast and that a massive piece of machinery carrying human beings could just vanish into thin air, leaving no physical trace for nearly a century.
And if we connect that modern reality to what we've learned today, it raises a new and entirely different question for us to consider.
What's that?
We have spent this entire deep dive examining how a lack of technology, a broken compass, a weak radio, an inability to see the stars killed early aviators. But today, our commercial aircraft are entirely flown by GPS, sophisticated algorithms, and satellite uplinks.
Right, it's all automated.
Exactly. We have engineered the uncertainty out of the cockpit. Have we swung so far in the opposite direction that modern pilots are losing the fundamental ability to fly manually?
Oh, that's an interesting point.
If a massive solar flare drops the satellite link tomorrow and the screens go dark, do we even possess the basic dead reckoning skills required to find the island anymore? Or are we, in our own technologically advanced way, just as vulnerable to the void as they were in 1937? And furthermore, if tomorrow an expedition finally pulls Amelia Earhart's Lockheed Electra from the bottom of the Pacific Ocean and proves it was just a simple, tragic fuel miscalculation, would we be relieved?
That is the ultimate question.
Or would the reality be a letdown compared to the 90 years of legendary myth we've built? Does the mystery itself now hold more cultural value than the truth?